We're at 432 Montgomery Avenue, Haverford Hunt Club, and I'm inside the roof access structure, and I'm showing you what a cross cut of that roof deck looks like. You can see it's hollow, and it's it's got its web design for strength. That's basically what. And here's you can see this is where it was cut. Where it missed the tube, the hollow tube. And here's what we found on the roof. First of all, we marked out some locations we thought were key in understanding what was going on. And those locations were near the drain, and we didn't go right at the drain because these drains have pans around them that are designed to waterproof the drain into the roof. There's a square pan that goes around these drains. We didn't want to cut through that, so we stayed just outside of it, and we made a cut right here. While we're talking about the drains, you can see that this is a Josam drain. And you can see that the repairs over the years have rendered this drain useless for future use. There's no access to the clamping system, which is buried under the roof cement right there. You can see all the roof cement. And basically there's a ring that goes around this drain that has bolts on it that hold down that lead pan I was telling you about. And that's the seal between the drain and the roof. Well, over the years people have just put roof cement over everything, and now all these drains need to be replaced. So back to the roof. Test cuts have revealed that you've got 1.5 inches of wood fiber insulation. That's this stuff. It's permeable, which means it absorbs water. The insulations today are for the most part non-permeable, which means they float on water. They don't absorb water. This stuff absorbs water, and it's detrimental in that it does, is that if you have a roof leak and it sinks down into this wood fiber insulation, you have trapped moisture that just has a negative effect on your roof above it. But the core sample we took right here is about 2.5, 2 5/8 inches deep from the top of the roof down to that deck that we just looked at, the concrete deck. And of that 2 5/8 inches, 1 full inch, the top, 1 full inch is built-up roofing. And that means layers of asphalt and slag. See the stone in here? There was a slag roof that was original to this roof, and then over the years people just kept putting asphalt on top of it. Now it's a gooey mess of nothing but asphalt and felts and whatnot. Here's some more of it here. You can see that there was a slag roof on here at one time, and then over the years people have put stuff on top of it. So you got about 1 inch of built-up roofing before the 1.5 inches of wood fiber that is put right on top of the deck with a vapor barrier underneath it. In other words, to describe the construction here, you had the deck, the concrete deck plank put down. Then they mopped a vapor barrier on top of that, which means they put hot asphalt on top of the concrete with a felt or something to act as a vapor barrier. Then they stuck this stuff on top of that with hot asphalt, and that's 1.5 inches thick. And then they went to the slag roof, which you have right here, and then all the other roofs that have been on this since. And I'm going to tell you, it's more than 2 roofs here. It's probably 3 or 4, because you have a whole inch of built-up roofing here. So that's what we found at this hole, and that's what we found at every hole. The same exact composition. 1.5 inches of wood fiber, and then anywhere from 1 inch to 1.5 inches of build-up roofing based on how many repairs were done in that area. Some areas had more repairs, and so the build-up roofing was a little thicker. But the key is that the insulation is all the same. Now, knowing that, the only thing we had to discover then was the elevations. You see, we set the transit up over here, so we had a clear sight line of most of the roof. And I didn't shoot every 10 square feet or anything close to that much. We didn't really need to, because we discovered pretty quickly that this roof is a dead level roof. This roof was installed dead level. That's why you have so many problems up here. There never was any canted design either in the deck or in the roof system itself. It's always been a dead level system. And I say that because all the cuts that we took revealed the same thing. All of these openings that we made have the same composition on them, and the elevations that we shot on this side of the roof were all within 1 inch of each other, probably a little closer than that, which means the deck was installed dead level. Now when we get to the other side has a twist to it, and that being that it's slightly lower over here. And we believe, from looking at this, we believe this was installed dead level with this side of the roof, but we think this side has settled a little bit, because we're about 1 inch lower over here. We have the same composition, the same stuff going on, but we're 1 inch lower, which kind of, I don't think it was intended that way. I think that this side of the building just settled, and that's just the way it appears. So you've got the same composition here. This is a little bit thicker here because of all the repairs in this area around this drain. And this area here, if you look at this, you can see how sunken it is here. It's got that swale in there. Well, this is what I was telling you about wood fiber being permeable. You can see it's saturated here, and as a result it's compressed down. So it's not standing up nearly as proud as the rest of the test cuts we took, because it's just got wet and it's just the weight has just compressed it down. So whereas we had 2.5 inches at the other test cut areas, this is under 2 inches right here because of the compressed insulation. So, trying to incorporate all this information into what comes next. The basic theme, as I see it, is going to be complete tear off down to the deck, and then a tapered system. You're going to have to go to a tapered system here because we've never had one, and you're having all these problems. The good news is that you don't have some convoluted tapered design in here, whether it be with the deck or with the roof, that's complicating the future. In other words, you have something that that you can start from scratch with here. You just have to tear the roof off and then put a nice tapered system in here. And something like that, if you look at this corner of this building here, just maybe a broad explanation of how that would work. The tapered system is going to divide this roof into quadrants or sections that are easily designed to drain. For instance, this area right here, this front square area that is on the one side here, you would have the drain in the middle, and then you'd have a valley going up this way, a valley going up that way, a valley going over here, and a valley going from the drain up to the corner of the building. And everything will be taped, all these triangles would be pitched towards the drain. So that would make this a positive drainage area. I'm not quite sure how the engineer is going to design this part to drain efficiently, but that's basically the plan, is segment the roof and put different rectangles and squares in to accommodate positive drainage. So that's what we have here. I'm going to put this together in a written report, and that's the way I see it. You're looking at formulating a specification. It's going to incorporate what we found today, which is basically a dead level deck with some settlement on that side that will receive a tapered system, which also means you're going to have to deal with the perimeters. Your tapered system is going to elevate your roof elevations at the perimeter, which means you're going to need wood nailers out there to terminate that higher elevation. This front area with the canted pent is going to be, that'll take care of itself. The wall will help too, but on these outside perimeters, you're going to have to put wood blocking to marry into the new elevation of the insulation. And you have the, you know, some complications here with the units, or the unit and the, you know, the pipe penetrations. They all need to be cleaned down, incorporated into the new roof. That's pretty vanilla. So that's pretty much what we found here. It's actually, you know, you look at it this way, you're just going to tear the roof down to scratch, down to the deck, and start over again. And that's, you knew you were facing a tear off anyway. The only difference is you're now going back with a tapered insulation to guarantee positive drainage.